T-SMARTY Dollar is a toolkit for the design of heterogeneous synchronous embedded system. It provides graphic modeling, simulation, verification, and code generation of single-block computation model. Let's start the tool and open existing project. This is the overall interface of the tool. Here we can see all the models contained in this project. First, let's see how to add a single-block computation model. An idle model has been added into the project. Here, you can add some atom block and component block. For the atom block, you can build some power automata here. For each element, you can edit its property at the property part. And then we can save the exchange. More detailed operations you can refer to the user manual. And we present a very complex example right here. This model is presented in the figure 2 of the paper. It generates the master frame that is sent on the multifunction vertical bus system. Here you can see some very complex power automata. Then we can do some graphic simulation here. First, we need to initialize the model. Then the model is initialized in the initial state, and the input data port and local variables are initialized, and the output data ports are initialized. Then we can input some value. And press the next button. We can see that the state and the output data ports has been changed and highlighted. We record all the traces here for your next simulation. After simulation, we can return to the modeling and then generate the extended label transition system for formal verification. Then we can see a file has been generated. This is the extended label transition system, which can be inputted into BEAGLE for verification directly. After verification, we can generate code. Let's see another example. This is used to control the sending process of the master frame that generated by the previous model. If we want to implement the model in hardware, then we choose export the model to VHDL. Then we can see that two VHDL file has been added in the folder. This is for the atom block. And this is for the component block that used to connect each atom block or the outermost component block. What if we implement it as software? We chose export model as C. Then we can see some software code has been generated. This tool is used to control the scheduling of each thread. We implement a barrier at this file, and this is for the thread implementation of atom block. It implements each automaton as a thread. And this is for the component block. We implement the function call for each sub-atom blocks or sub-component blocks. In a similar way, we can construct some more complex model like this and then generate some code for them. After that, we can load those files, these codes, into the Microsoft Visual Studio or Langlix ISE for hardware simulation and software simulation. Then we can generate a bit file and load them into the FPGA processor and ARM processor as presented in the paper. For more details, you can refer to the official website of the T-Smarty Dollar and the job box that you can download some user manual, quick start, and also the video. Thank you.